welcome to this episode of Night Sky News for March 2023 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next couple of weeks, and we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about the asteroid that will most likely not hit Earth in 2046, JWST's latest spectacular image of a star pre-supernova, and evidence for current volcanism on the planet Venus. That one is a big deal, so I'm excited to chat about that. There are chapter markers down here if you want to skip ahead to any specific news story, and any research papers that I mention are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. All right, hopefully most of you saw the beautiful conjunction of Jupiter and Venus in early March. I managed to spot this along with the Northern Lights on my trip to Iceland last month, which was absolutely incredible. Thank you to everybody who sent in their astrophotography shots of the conjunction. They were great to see. Now, since then, Jupiter and Venus have moved further apart in the sky, but you can still spot them in the western sky just after sunset if you want to. Plus, on the 23rd and 24th, the crescent moon, aka the Toenail moon, will be very close to the bright Venus, and it should help you to pick it out on the sky. If you look early enough after sunset and you've got a clear view of the horizon with no trees or buildings in the way, you should also see Jupiter very low in the sky. So low, in fact, that on the 27th of March, it will pair up with the much fainter Mercury, very close to the horizon. So if you've never spotted Mercury before, because it is very faint and the only time we ever see it is close to the sun, so that's either just after sunset or just before sunrise when the sky is still very light, then this could be your chance, because Jupiter is going to be much brighter because it is so much bigger, the planet Jupiter, compared to Mercury, so it should be easier to spot on the sky. If you don't have a clear view of the horizon though, then you should keep your eyes up to the moon that week, because after passing by Venus on the 23rd and 24th, it swings past the star cluster Pleiades on the 25th. That sort of looks like a mini plow or mini Big Dipper, whatever you call it. And then the moon swings past Mars on the 27th and 28th. In fact, if you have binoculars, you should be able to see both the moon and Pleiades at the same time as you're looking through your binoculars, which should be a great sight. Remember that the moon is much brighter than Pleiades. So once you've found Pleiades by sort of hopping off the moon, you should then position your binoculars so that the moon's like just out of shot, so that you get rid of the brighter glare, so that your eyes can adjust and see much more detail in the Pleiades star cluster. So you might just be able to see that there's sort of like a fuzziness around the stars, which is the diffuse gas surrounding the cluster, you know, that's left over from the formation of those stars. Then by the 11th of April, Venus will have shifted to be right next to the Pleiades star cluster as well. So if you miss the pairing of it with the moon because of, say, bad weather, keep an eye out for this one. Again, you should be able to see both of them at the same time if you look at them with binoculars. But you're going to have to be quick about it, because they're only going to be around for an hour or two after sunset before they too will set. As we get further into April as well, keep an eye out on the sky for meteors, or shooting stars as they're sometimes called, so bright points of light streaking across the sky as tiny bits of rock and dust just burn up in the Earth's atmosphere, usually caused by some debris left over by a comet. I'm talking about the Lyrids meteor shower, which this year is predicted to peak with the most number of meteors per hour on the night of the 23rd of April. The best view is from the northern hemisphere and in the darkest skies with no moon, thankfully, this year either. You're looking at around about 10 to 15 meteors per hour. So not the most active of showers. You're looking at around about one meteor every 4 to 6 minutes or so. But we have such a dearth of meteors every year from like January to April that I always get excited when April rolls around, you know, just for the possibility of the Lyrids meteor shower, because you never know, they're unpredictable. They could always surprise us. The best time to look for them is just before dawn. So this might be one you might have to get up especially early to see. Maybe you're up early anyway. And as I said, the best view is from the northern hemisphere because the radiant, the point in the sky where all the meteors are going to appear as if they're shooting away from, is quite high in the northern sky. So if you're in the northern hemisphere, you're probably going to catch all of those meteors if you're in a dark enough sky. Whereas if you're in the southern hemisphere, you're only going to see the ones that actually shoot southwards and come up over your horizon. However, the Lyrids are known to leave like a trail of gas behind them that glows for a few seconds, you know, after the very bright meteors shoot across the sky very, very quickly. So keep an eye out for that. To make up for the fact, though, that those of you in the southern hemisphere aren't going to see as many meteors, you do have a total solar eclipse coming up on the 20th of April. This is when the moon passes in between the sun and the earth. And on some parts of the globe, the alignment is just right for the moon to block out all of the light from the sun. This doesn't happen every month though, because the moon orbits the earth at about a 5-degree tilt to the earth-sun orbit. So the alignment isn't always right. So this is where the eclipse is going to be visible. Now the darkest purple line on this map is the path of totality. So you can see that it just clips right on the edge of Western Australia. I believe that's Exmouth, Western Australia there. It also goes through East Timor and then also the eastern parts of Indonesia. Everywhere else on this map will just see a partial eclipse. So as you get further and further away from that path of totality, less and less of the sun will get covered and you'll just see it looking like there's sort of like a bite been taken out of the sun by the moon. I'll pop a link in the video description below so that you can see what it's going to look like for you in your location and what time to look as well. I feel like it's my duty to reiterate that you should not look directly at the sun. It will cause serious damage to your eyes. If you want to actually observe the total solar eclipse, then you're going to need to get either specialist eclipse glasses so that you can view the sun safely with most of the light filtered out. Check them though if you've got old ones for scratches or dints or anything that makes them imperfect that again could damage your eyes. Or you can make a pinhole camera. I'll put links in the video description below that give you instructions on how to do that. Or one of my favorite things to do is just to hold a colander, a vegetable strainer, over your shoulder, project the image of the eclipse down onto the ground through all those holes in the colander, and you'll be able to see what the sun looks like at that time. All right, that's enough of looking up at the night sky, or the daytime sky in the case of the eclipse. Let's come back down to Earth and chat about what's been happening in space news in the past month. All right, to kick things off, the date for the launch of the European Space Agency's, or ESA's, Jupiter Icy Moons Explorer mission, or JWST, has been set for Thursday, the 13th of April. Just like JWST, it's going to launch on an Ariane 5 from ESA's spaceport in French Guiana, and it's going to do a lot of gravity assists around planets in the inner solar system in order to get it to Jupiter. So it won't actually arrive at Jupiter until 2031, so we've unfortunately got quite a long wait. But once it's there, it's going to start studying 3 moons of Jupiter, Ganymede, Callisto, and Europa, and assess their habitability for life, because they're all thought to have liquid water oceans under their icy crust surfaces. And who knows what they could be hiding under there. So it's a really exciting mission. I'm going to be watching the live stream of the launch with all of my fingers crossed. If you want to do the same, I'll pop a link in the video description down below to wherever you can watch it to. Next up, I want to talk about the asteroid 2023 DW, which is thought to be around about 50 meters in diameter. It was first discovered on the 26th of February 2023, when it was around about 10 million kilometers away from Earth, or to put that into context, that's about 26 times the Earth-Moon distance. So when it was discovered, it was observed over the span of around about 17 hours to see how its position changed with time. And from that, you could then work out its orbit and run that forward to see where the orbit would take it in future and if it posed a threat to Earth. Now, how accurately you can predict where an asteroid's going to be in the future depends on how precise those positions are that you measure night after night for where the asteroid is. And those uncertainties on those positions snowball the further in time that you run the asteroid's orbit forwards. Now, with those initial observations from the discovery of the asteroid, the first prediction of the orbit could be made, and that prediction put it coming within 1.8 million kilometers of Earth on the 14th of February 2046. That's around about 4.5 times further away than the moon, and gave it a 1 in 560 chance of being deflected off its orbit by Earth's gravity and impacting the Earth. 1 in 560 chance? It's pretty high, actually, and it puts it at the highest probability of impact with an asteroid that we currently know of, and put it at a level 1 on what's known as the Toenail scale, which is a combination of the probability of the impact based on the orbit and the kinetic energy of the asteroid, i.e. how big is this asteroid and how much damage could it cause. Now, the scale goes from 0 to 10, and we currently, before this discovery of this asteroid, did not have any asteroids that went above a level 0. This asteroid 2023 DW was classed as a level 1, and the definition of a level 1 is a routine discovery in which a pass near the Earth is predicted that poses no unusual level of danger. Current calculations show the chance of collision is extremely unlikely, with no cause for public attention or public concern. New telescope observations very likely will lead to reassignment to level 0. So hopefully that just puts all of this media hype around this asteroid into context for you. Something else that might help put this into context is, yes, the prediction was that it would come within 1.8 million kilometers of Earth, but the uncertainty on that estimate was plus or minus 21 million kilometers, which is about 54 times the Earth-Moon distance. And lo and behold, since those first observations that were only taken over, 17 hours, we've now got 104 observations that have been taken over 17 days that have refined that estimate of, how close the asteroid will pass to 3.2 million kilometers away from Earth, and have dropped the probability of impact to 1 in 1,000, and that probability just keeps dropping with every new observation we get. In fact, NASA, while they still have it as a level 1 on the Toenail scale, ESA have already downgraded it to a level 0 on the Toenail scale. So honestly, this is nothing to worry about. All right, next up, I want to talk about this research paper from Crook and collaborators that looks at the impact of satellites on Hubble Space Telescope images. Now, the lead author of this paper, Shandor Crook, is my academic baby brother. We had the same PhD supervisor, essentially, and seeing him published in Nature paper makes me all kinds of proud. But let's chat about what this paper actually found. Now, we hear all the time about the impact of satellites in orbit around Earth on the night sky that we enjoy, from our back gardens, but also on professional astronomical observatories as well. Especially these huge satellite constellations of tens of thousands of satellites, like the ones that are planned for Starlink by SpaceX or OneWeb by Airbus. And usually the arguments that you hear from people who are in favor of these satellite constellations is that we should just stop using ground-based observatories anyway, and we should just start launching more space telescopes, which is already a poor argument because, space telescopes don't have as long a life as ground-based telescopes. They're not as easy to maintain or even switch out the instruments for new instruments, newer tech that, the same telescope collecting light, but newer tech recording what it actually sees. And also space telescopes are hugely oversubscribed. You need ground-based observatories to actually keep up with the demand from astronomers. But as it turns out, Crook and collaborators have now looked at Hubble Space Telescope data and found that an average of 2.7% of Hubble Space Telescope observations every single year are affected by satellites moving across the field of view and reflecting sunlight back to the telescope. Plus, that fraction of images affected is growing year on year with the increase in the number of satellites. Now, Crook and collaborators did not set out to start studying this. It came from something completely different. A citizen science project that got volunteers, i.e. members of the public, to classify archival Hubble Space Telescope data to look for asteroids, which leave trails on the long exposure images the Hubble Space Telescope takes that appear as these sort of short, curved tracks as Hubble orbits orbits the Earth. But volunteers also spotted long, straight tracks caused by faster moving satellites streaking straight across the telescope's field of view, and then flagged them to astronomers on the project's forum. So from there, Crook and collaborators then realized that what they had was essentially a subset of the Hubble Space Telescope archive that had been labeled by volunteers as containing satellite trails. Then what they could do was use that to then train a machine, a computer, to then look for other satellite trails in the entire Hubble Space Telescope image archive. Then they could work out the total fraction of images taken by the Hubble Space Telescope that were affected and look how that was changing with time. So in the blue here, you've got one instrument on board the Hubble Space Telescope. It's the Advanced Camera for Surveys. And then shown in yellow, you've got another instrument, the Wide Field Camera 3, which was actually installed in the last Space Shuttle servicing mission of the Hubble Space Telescope back in 2009. And you can see that on average, around about 2.7% of images are affected. But that is also increasing, so that in 2021, around 5% of advanced camera survey images were affected. This is because the Hubble Space Telescope is in a low Earth orbit at around about 538 kilometers in altitude. But that altitude is dropping all the time because of atmospheric drag. I actually made a video about this just a few weeks ago. If you want to check it out, I'll link it up here and in the video description down below as well. Now, one of the main Starlink shells of this satellite constellation is at an altitude of 550 kilometers. So it's no surprise that they are affecting the Hubble Space Telescope observations, and that number is going up as Hubble drops and they launch more satellites. Now, we've currently got around about 5,500 satellites in orbit around Earth right now. 1,562 of those are Starlink satellites and 320 are OneWeb. And the number of satellites in low Earth orbit, like where the Hubble Space Telescope is predicted to be between 60,000 and 100,000 by the end of the 2030s. Now, the current probability of a Hubble Space Telescope observation being affected by a satellite is around about 5%. But with that increase in the number of satellites by the end of the 2030s, that's set to rise to be somewhere between 20 to 50%. Now, there are ways that you can remove satellite trails from images as long as it doesn't go, right over your target of interest. If you're observing very large targets like galaxies, for example, like I do, that's obviously much more likely. Smaller targets like stars, perhaps that's less likely. That's also much easier for higher altitude satellites, which appear much smaller and cover less pixels in an image. But lower altitude satellites like SpaceX's Starlinks will appear much larger, covering up to 120 pixels across the detector, which would massively minimize the scientific usefulness of any image. So it's not exactly an optimistic outlook for either ground-based observatories or space-based observatories in astronomy, at least those in low Earth orbit. But now that we do actually have some numbers on the percentage of images that are actually affected by this, thanks to this research by Crook and collaborators, it means that we can now work with satellite companies who are planning to launch a lot of satellites to hopefully minimize the effects to astronomical observatories. All right, on to JWST news now, which thankfully is not affected by satellites because it is 1.5 million kilometers away from Earth, orbiting a point known as Lagrange 2. This month, we saw another release of a deep survey image from JWST, this one known as Cosmos Web. When it's finished, this will actually be the largest program in JWST's first year of observing, i.e. it'll cover the largest area of sky. And on the 9th of March, they released this first image from the survey, just one section of that big planned mosaic of sky that will eventually cover 3 full moons. This image covers around about 10% of the area of the full moon. So it's great to see this sort of mosaic mosaic slowly coming together, and I'm really excited to see the science that will eventually come out of this survey. If you want to have a look at a very high-res version of this image yourself, I've popped a link in the video description below for you to download it. Sticking with JWST, another image that was released this month was this spectacular one of what's known as a Wolf-Rayet star. Now, as far as I know, there's no research paper that accompanies this image. As far as I can tell, it's just a press release from NASA from the early release observations that were taken way back in June 2022. What that means is that it was a contender for those first 5 images that were released by the JWST team back in July 2022, but they just ended up not choosing it. They've released it now though, because let's be honest, it is spectacular, and also it helps any stellar astrophysicists out there, plan their observations with, more data they have to tell what JWST is capable of. So what you're seeing here is a star very close to the end of its life. It's putting off the inevitable supernova for as long as it can. You've got the bright star in the middle there, and then you've got all of this cooler dust and gas around it. So the redder the colors are here, the cooler the object is. It's giving out longer infrared wavelengths. And the bluer the objects are here, that means the hotter they are, giving out shorter infrared wavelengths. And all of that gas around it in the reddish colors is what used to be the outer atmosphere of the star, which as it's run out of hydrogen in its core to fuse into helium, it's thrown off all those outer layers. You've been left with the core, but that core is still fusing helium into heavier elements, or maybe even some carbon into heavier elements. For that to happen, it has to be extremely hot. So that central star that you're seeing there is anywhere from 20,000 Kelvin up to 200,000 Kelvin in some cases for Wolf-Rayet stars. For this star, Wolf-Rayet 124, it's already shed 10 suns worth of matter out into that surrounding gas that you see. The star in the middle is still 30 times the mass of the sun. So this phase is something only the heaviest stars go through, which don't live very long. So it's very rare to catch a star in this phase at all. But they are crucial to our understanding of how the heavier elements like carbon, nitrogen, and oxygen were all first formed in the early universe and how they were spread across it as well. Because if you look at this image, you can see there's a lot of dust blocking the light. That's the heavier elements clumping together into these little dust grains, and then maybe even clump together further to give things like asteroids and then planets, and then even whole planetary systems around stars like the solar system. So because these stars are the shortest lived, they don't live very long, stars like this one will have been the very first in the universe to make anything heavier than hydrogen or helium, and maybe even seed the very first planet formation. So we're studying stars like this one that we see in this image, this Wolf-Rayet star, we can understand better how that whole process happened. And finally, let's talk about this new study from Herrick and Hensley, who claim to have found evidence of active volcanic eruptions on Venus from images taken by the Magellan mission way back in 1992. Now, first of all, some context on why this result is such a big deal, because from reading people's reactions online, I think a lot of people were confused because they were saying, well, haven't we always known that Venus is like a volcano world? And yes, we have. Venus's surface has very clearly been shaped by volcanoes in the past. Its surface is 90% basalt, and there are lava plains everywhere, and there are over 1,000 structures on the surface of Venus that look just like volcano structures, or structures that are made by volcanoes here on Earth. And then there's the 8-kilometer high Mons, thought to be a shield volcano like Mauna Loa in Hawaii, or Skjaldbreidar in Iceland, or Olympus Mons on Mars. Now on Mars, we know that Olympus Mons is not active. We know that Mars is not volcanically active at all because we can very clearly see its surface. We've had probes in orbit around Mars for decades now, and we've not seen any changes to that surface that would clearly come from lava flows or volcanic eruptions. Problem with Venus is that it has a very thick, toxic atmosphere with these yellowish clouds of sulfuric acid trapping in the heat that resulted in that runaway greenhouse effect on Venus. So we can't easily study the surface. We can't just take direct images of the surface. Plus, we only actually have one probe in orbit around Venus right now. That is JAXA's Akatsuki mission, which is studying Venus's atmosphere, not its surface. It did have an infrared camera on board that was going to look for the heat signatures of volcanoes on the nighttime side of Venus, but unfortunately that suffered an electronic failure back in 2016. The Indian Space Research Organization, ISRO, have Shukriyan planned to launch in December 2024, which will have a radar instrument to map the surface through the clouds. And similarly, NASA has plans to launch the Veritas mission in 2028, again to map the surface of Venus with radar. But until then, the most detailed radar mapping of the surface of Venus that we have comes from the Magellan mission back in the early 90s. It was launched back in 1989, piggybacking on the Space Shuttle Atlantis' STS-30 mission, which then deployed it from Earth orbit. It arrived at Venus in August 1990 and then spent about 4 years mapping the surface of Venus using its radar detectors. After that, it was then deorbited, it crashed into the surface of Venus, and all communications were lost from it. Now, the way they did this was that it would image parts of the surface every full rotation of Venus, which takes 243 Earth days. These were called cycles, and it ended up with 3 cycles by the end of its mission. On the first cycle, the radar images were taken with the spacecraft passing overhead looking eastward. Then on the second cycle, they filled in the gaps, flipping the spacecraft so that it looked westward. And then in cycle 3, they filled in any more gaps they had, again with the spacecraft looking eastward this time, but at a different angle, at around about 20 degrees to the first angle that it looked at. By doing this, they managed to actually map out 98% of the surface of Venus with radar, but there was a lot of overlap. So 8% of the surface was actually covered in 3 of the cycles. 42% of the surface was covered in 2 or more cycles, which is actually great if you want to look and see if anything on the surface has changed in the space of, what, like 200 days because of volcanic activity. However, because the perspective was ever so slightly different, with it looking east one way and then with it looking west when it was going for cycle 2, it meant that the perspective on these images were different, which means that a lot of things change from one cycle to another, which is not really something you can train a machine to actually pick out because, well, every image is going to change, even if there are actual surface changes in that image. But it is something that humans are very good at picking out. We do this all the time in our daily lives. We deal with this concept of perspective and seeing things from different angles. So one of the authors of this study, Herrick, spent 200 hours manually going through and comparing regions of the surface image more than once by Magellan. And they found one region that looked different in the Alta Regio region of Venus, a vast highland area near the equator where you'll also find Mat Mons. Herrick found a vent associated with Mat Mons that he thought looked different in the cycle 1 image taken in February 1991 compared to the cycle 2 image taken in October 1991. So here are those images. Remember, they're taken from 2 separate angles, so they're not going to be identical, but the main features here do look like they have changed. So this vent appears to be unchanged, right? There's similar shapes in the 2 images, even though you're looking at it from separate angles. But you can see how this vent has changed shape, more than like just seeing it from a different angle could explain. It even appears to be shallower, perhaps even filled by lava. Plus, you've also got this new area that's brighter in the radar image that could be new lava flows. As you can tell, comparing these images is rather difficult because of the different perspectives, but also because of the low resolution 90s images that you've got as well. And that's when the other author of this study, Hensley, got involved to create 3D computer-generated models of the surface of Venus that you could then observe from different angles, just in the same way that the Magellan data was taken, and then you can compare that to the observational images you have. So we can see those simulations here. We've zoomed in on an unchanged event labeled U and a changed event labeled V. You can see that the computer simulation is a great match to both vents in cycle 1. Those are the images on the left there. But the images on the right are the cycle 2 images. And the unchanged vent simulation is a good fit, but it's a very poor fit to the changed vent, suggesting that that change in shape is not due to the fact that you've seen it from a different angle with the 2 observations from Magellan, but that vent really did change shape, presumably because of volcanic activity in the time between February to October 1991. Now, these vents are kilometers across, and the authors point out that on Earth, there's no known process that could change such a huge event other than volcanic activity. So the authors concluded that the only way to explain this observation would be if volcanic activity was ongoing on Venus. Now, this is just one data point. The authors did not find any other change in the surface in the data that they have from Magellan. So while it is a promising data point, it still is only just one. But it does lend a lot of excitement to ISRO's Shukriyan mission and NASA's Veritas mission that will both map the surface at much higher resolutions. Plus, the data from those missions will be put online and made publicly available, so you can get huge amounts of people searching through the data, just like with the Asteroid project on the Zooniverse that I was talking about before, so that, changes like this don't go missed in the data because that data's just been buried in archives or on CDs somewhere for the past couple of decades. I mean, the end goal here really is to determine, what is the volcanic activity on Venus? Is it very low? Is it the same as Earth? Or is it as high as Jupiter's moon Io? Which all comes back to our understanding of how did the solar system form, why are some planets more volcanically active, and how did we end up on Earth, asking these questions in the first place. All right, that's it for night sky news for this month. As always, if you snap any pictures of the night sky, or if you see any space news stories online that you want me to explain, then send them my way over on social media, and I will do my best to try and cover them in a future night sky news episode. Until then, though, everybody, happy stargazing. For March 2023, roll that every time April rolls around, rolls around. This is a little cube. Oh, look at the little cube on my eye. Focus, focus, focus. Sorry, Becky, focus now. Somebody's honking their horn outside. How rude. Month. I keep saying month weird, and I keep catching my month. I'm gonna say it again. I don't know why. It's annoying me. ESA have downgraded this astronaut. I don't even know what that word that was. Asteroid, astronaut, I had no idea. It was launched in 1989, piggybacking. During that time, it would image parts of Venus's surfaces.